Abstraction. The art of making beautiful things ugly and ugly things beautiful. I guess it's a bit like alcohol. 1 minute you can't get enough of it, and the next you're vomiting it all into the toilet. The love-hate relationship that all programmers have with abstraction is the topic of this video, so welcome. We're very early on in making my game, Taylor. My focus is to get a prototype for my combat system. In the first coding devlog, I explained my hybrid combat system, which falls between turn-based combat and real-time combat. You don't need to have watched all the details, so I'll abstract them away from you by saying it was, well, quite complicated. It adds quite a lot of complexity to my code. Okay, so imagine this. You're the player character. You're all hyped up like Ash Ketchum, and you're ready to wreck your opponent, not with Pikachu, but with a slipper. So, as a programmer, I need to add a button. When you click on it, I know you want to throw the slipper. Like all other abilities, that slipper needs to do a lot of things. So, it seems like a sensible thing to make an abstract ability class. We subclass this abstract class to give us a concrete ability class, all as well. When we write the code for a battle, we don't need to worry about the specific implementations of a slipper or jumping. That's all abstracted away for us in the ability subclasses. Hang on a second, a class per ability? Kenny, come on. Your abilities aren't special snowflakes, they share a lot in common with each other. For example, the logic for any kind of projectile is the same. The only difference is the 3D model. You want to be able to abstract away the few differences between the different projectiles. So you have a single projectile ability class, but then to create different types of projectiles, you have different 3D models. We usually use data files to specify these abilities. In that file, we can specify a type of projectile, a name of slipper, and the model to slipper.glb. One of the reasons we write in data files instead of code is that it allows non-programmers to add new things easily in, for example, mods. In Godot, the game engine I'm using, resources are how you would achieve that. You have a class, let's call it ability data, which defines the structure of .tres files. We'll have a slipper.tres file and a jump.tres file. In the future, we could add a rock.tres file. Both the rock and the slipper abilities could use the same projectile ability class, just with different values. Here, we've abstracted the logic of our abilities from the precise values that they act on. Life is good. How do I make the slipper appear when it's thrown? Well, I could add it to the player, but then when the player moves around, so does the slipper, even when it's midway through the throw, so I need to add it to a node that doesn't move around, like the main world node. But the player, being a child node of the world, doesn't directly have access to the world node. Also, children shouldn't know directly about their parent node, since they should be able to be placed anywhere. So, context class maybe? The main node would pass itself down to its children, wrapped in some kind of ability context class for convenience. The slipper then can directly access the main node and add itself to it. But isn't it dangerous to pass the whole world state to the slipper ability? Given access to the main node, we can delete the whole world. Also, there's a requirement on when you can use abilities. You know, needing enough energy or something like that. My abilities probably have very different requirements. I could attach a script to each of these TRES files and then specify the logic there. But there's going to be so many abilities, so that's surely not a good idea. Also, these are meant to be data containers, and now suddenly we're adding game logic to them. And we can't add a method to the ability class, since we can only access an instance method if the ability object is created, but the ability object would only ever be created if the canUse method told you that all the requirements had been met. Calm down, Kenny. Why don't we add another class? Like an ability definition. This composes, yes, that's right, this composes ability data, and it also has this canUse method. We can create instances of this, no problem. Yes, that's right. Oh, Kenny, you're a genius. Wait, how do you know which ability data instances match with what ability class and ability definition? Like, how do we know when we've got a slipper ability data instance that we match it up with a projectile ability class? And remember, we're potentially going to have hundreds of abilities. Reflection? No, way too hacky. Adding the path to the correct ability class as a field in the ability data class? No, that sounds like hell if I need to move things around. Maybe I inherit from ability data, and then each child class has a method which creates the correct ability. No, that sounds way too unelegant. Enum's a switch case, maybe? I mean, it'll be fast, but then what if I want to have mods in my game to add extra abilities? Plus, if I have 100 abilities, then that will be 100 cases I have to deal with. Oh, actually 101, since there's also the default case. Either way, that's way too long. A singleton registry class, maybe? A static registry class? But then, I had a vision. Hang on. Remember your training. You're trying to optimize a game so that it can handle 100 different abilities, but you have like 2. You're trying to optimize a game so that it can handle mods, but your characters are literally mannequins. As for singletons, remember, you are single, and you weigh a ton. There's no need to impose your insecurities in your code. Now, farewell. I realize now. Abstraction isn't evil, it's just very difficult to know how much you should have. Whether a potential solution is over-engineered or is actually not complex enough can be quite difficult to tell ahead of time. While some thinking is useful before you jump ahead into coding things, I found it more useful to just try and implement features and make whatever abstractions I wanted as I go along. After you have a good enough idea of the various systems, then you can see where you can make improvements. The point is, you need data to evaluate what the correct solution is. The data comes from experience and from your codebase itself. Both of these things are extremely lacking for me. That's why I failed. I got scared of all the abstraction when it would have been so easy for me to remove it later on. So I don't really have an elegant solution to present to you. All I have is the code that I've written after many hours of overthinking. We're not really much further than we were last devlog in terms of actual game features, but we have progressed in terms of refactoring. How fun. So don't be like me. So thanks for watching. Please watch my other devlogs and bye.